welcome to a new discussion, and this discussion basically is related with the demonstration of digital image processing software, and we are going to see here a different demonstration on a satellite image, especially about the false color composite. But as you know that we have been going through this slide, there are two types of softwares, public domain and commercial. And today the demonstration which I am going to have on a commercial software which is on ArcGIS, and we will see that how this false color composites are formed and how different permutation combinations can also be done here. So we go back to that option, that software. In the earlier discussion also, we left with this image. This is raw image of a spot satellite of Moscow, and there are 3 layers. But the first time when you add this image, there will be a different scenario. So what I am, in order to demonstrate this one, what I will do, I will first remove this image, and now I will add here. So I will get the access to this image, and this is stored in a TIFF format in this Moscow spot. And when I add this image, this comes in a completely different colors. And these I deliberately did it, otherwise I would have already done it on the already displayed image, but I have removed it and again brought back. So when you double click here or in any other softwares, the purpose here to understand how false color composites are made. The purpose is not how false color composites are made or handled in ArcGIS. I am no way advertising any commercial software, but in order to demonstrate things, we have to use some softwares, and therefore I am using this software. So if I see here that red band is layer 1, because this is a multispectral image, and red band is layer 1, which is not true. It should have been in fact here the layer 3, that is infrared channel, the band 3 should have been here, and instead of in blue, and the layer 3 instead it should be 1, and 2 will remain, and the green remain for the layer 2. So when I choose this one, and even if I don't go for this gamma stretch and no stretch at all, just go for this kind of options, then this is what the false color composite image which I see here. So as you can see here that now I am getting a false color composite. Remember, false color composite in which the vegetation appears as red, because red channel has been assigned, the infrared channel has been assigned red color. That also we will see now here. So what I am going to do, I will repeat I will repeat the layer 3 which I know is band 3 or infrared channel, and in all these 3 layers. So virtually what I am going to have a gray image. This is what you are seeing here now is a gray image, and that gray image is nothing but the band 3, that is infrared channel. As you can see here that in this particular part, this is the brighter part, and this is also a brighter part where you are having a the high density of vegetation. Also the vegetation is present in other areas as well within this image. So that is why when we go for false color composite, like here when I go for band 2, now band layer 2 or band 2 or layer 1 here, again I go back and I get a false color composite. So this is how false color composites are formed. If that combination is not followed, then you are not creating a standard false color composite. There are keys, standard keys are also available to interpret a false color composite image. But if I choose a altogether or default for this composite, then I am having problem there. Like here, when I displayed this image, the arrangement was something like this. And what we are seeing an image having that arrangement was also had a gamma stretch by default, and the image was looking like this. That is not false color composite, and therefore interpretation of such image is very difficult. So, if the image is already in 3 bands multispectral image and it has been prepared by some other through some other software in a false color composite, somehow the softwares may take band 1 in the red color like here, and green band 2 in the green channel, and band 3 in the blue channel. If this is the scenario, you are not getting false color composite, though the original image is false color. So, best thing is assign band 3, that is the infrared channel, red color, and band 1 blue and green as it is, and then you choose this one, and of course, then you get a false color composite. So, single image will definitely look individual single image as I was showing in the infrared channel, that these areas had the maximum brightness, and as you can see also in the false color composite, since we have assigned red color and therefore they are appearing as red. Now, the water body here, water body which is a basically river, is appearing dark here. Why? Because now we are not using single channel, but we are using multiple channels, and in these channels the water bodies are having very dark signature or dark pixel values, and therefore water body is appearing dark. Plus, in particularly in infrared channel, what we see is the water basically having the infrared energy is absorbed by the water completely, and therefore a fresh water or clear water will always have a very dark signature. So, what I am going to do, I will again change these values, have a gray scale here, and likewise, and apply again, maybe without or maybe with the gamma stretch, and when I say OK, this is what I see here. Now, see, just focus, earlier we have been focusing on vegetation, now focus on water bodies. So, and mainly the river, and this is all appearing dark, vegetation is having high reflectance. So, recall your these spectral signature curves or spectral response curves, and in infrared channel vegetation will have high reflectance, healthy vegetation will have a high reflectance, and this is what you are seeing. Water body, a clear water body will have complete absorptions, almost complete absorptions, and will appear dark in the infrared channel. Now, we will be also going through the other channels and see what are the responses in the visible part of EM spectrum, and especially 2 channels, one belongs to the blue part of EM spectrum and another one belongs to the green part of EM spectrum. So, if I go here and instead of having all 3, I will now choose say band 1 in all these 3 layers. So, that means I will be displaying only band 1, and which is basically the blue part of EM spectrum, the first band, and this is what you are seeing. Now, focus on the vegetation part, which has the healthy vegetation in the infrared channel. Here is appearing dark. So, in blue and green, in green you may have some reflection of the vegetation in the visible part, but in the blue part of EM spectrum you will not have anything. Water body again still appearing dark, but that kind of contrast in water body and vegetation and other objects which we have observed in band 3, that is infrared channel, is not seen here. So, if I do it a little different way, now I bring the band 2 here, and that is our green band here, and apply this one, see that now vegetation is having some reflection, but still it remain dark, and water body is also remaining dark. So, when in all three channels, blue, green and infrared, water body is appearing dark, and therefore, in a false color composite also the water body will be appearing dark, as I am going to demonstrate again, going back to our original false color composite. This is what it is. So, if because there are three channels are being used to create this false color composite, and for infrared channel we are assigning red color, therefore, vegetation is appearing red, because in infrared channel vegetation is having high reflection. Water body in all three bands, blue band, green band and infrared band, water body had the black signatures or dark signatures, and therefore, in color composites also, whatever the color composites you will create, it will be always dark. So, if I go back to the default one, which has the in normal sequence in descending one or ascending one, whatever the way you want, and if I apply, this is what I was getting initially when I added this image, and again, but notice that water body is still dark, because in all three channels it is having dark signatures. But if in one channel a object or features are having brighter signatures compared to other bands like blue and green, for example vegetation, then whatever the color you will assign to infrared channel, that color will be for the vegetation. In this default one, the blue color has been assigned to the infrared channel, and that is why you are seeing a different scenario here. Let me bring back, this is 3 and this is 1. So, now we have come back to the original FCC, and things are now here in that way. So, whenever you create a false color composite, first of all you need to have 3 channels. One, also you need to have one infrared channel and 2 other channels, blue and green. This is a standard practice of creating a false color composite, because interpretation of false color composites, you are also having interpretation keys, which we will be discussing in other lectures. So, for that purpose, and everyone understand about standard false color composite. So, you need to have 3 channels, one infrared, blue and green, and when you assign red color to the infrared, blue to green and blue likewise in a reverse way, then you get a standard false color composite as being shown here. And of course, the stretch part will also come here, that you can start stretching generally in the default it will go for some standard deviation or histogram equalization. One has to be careful that you see first what is the scenario in when I am not going for any kind of stretch. This is the scenario, no stretch is being there at all. This is the original image, and this is how whenever you get a original satellite image without any enhancement, image enhancement techniques, and I am not discussing about atmospheric correction or radiometric correction or geometric correction. I am discussing about the image enhancement, because those corrections will be done separately, and some are like radiometric corrections generally are done by the agency who supplies the data or put on net, and this atmospheric corrections is done by the users as per their requirements, and georeferencing also one has to do it, that will be also done by the user. Now, here when I do not have any stretch, so when you get an image and display first time, and if in default this option is for a stretch type is chosen none, then this kind of display, a dark image without much contrast, without much brightness you would see. And if you see the histogram, this is what you see here, that most of the values are within the range of minimum value in this scenario in this particular image is 26 and maximum value is 253. But there are only few, see the frequency that is frequency axis, that is y axis, hardly few values are having 255 values or 253 values. Rest are the just in between. Maximum values are located between this part and this part. And so here this one is around 127 value and this value is around 26 or 25. So minimum value of course is 26. So within that range the maximum values are located, and the highest frequency value, the count you are having is this one, which is around mean value, which is 68 value. So initially the histogram is not occupying the full space or full range of pixel value which is available in 8-bit scenario is 0 to 255. This is the 8-bit scenario which we are discussing. Now when we go for any kind of stretch, these values are redistributed. So we will now we will go back and see the after stretch. So if I go and choose the first option, or rather the second option, that is standard deviation, and without going for any gamma stretch options or any other thing, just apply this standard one, and the value n is 2.5, and this is what the contrast it has created. Suddenly the image becomes very bright and having contrast as well. Now when I go back to this histogram, this is what I see. Originally is also shown in grey color, and the redistributed one, that means the stretched one through standard deviation 2.5 value standard deviation, it is now it is occupying the full dynamic range, and therefore our image has started looking brighter as well. So this way we start doing our image enhancement. I will repeat again that this is not necessary that for all the images we will do the same way. It is not. It depends on image to image, and even if image belongs to the same area or different season, different enhancement techniques would be performed. One. Second is, if you are going for further processing like classification and other things, it is better not to do lot of stretching to your input image, because after all you are going to for this pattern recognition or object recognition through the classification, and that may create problem there. So it is better not to do too much stressing or no stretching, and for classification purposes. Otherwise for display purposes, for interpretation purposes, and using some other for other purposes, definitely one should create better contrast and brightness in the image. Otherwise the this original image looks very bad for any purpose. So for that we have to do this. Now I will also go through the some other stretches which are available, and stretch type you can choose. Histogram equalization, very quickly I will go. Histogram equalization here, and when I apply, see the results are completely different than in the that standard deviation. Histogram equalization will create very much contrast, too much contrast in the image, and darker areas have become much more darker, brighter areas has become much more brighter. One can also when we go for this kind of stretches like minimum maximum histogram specifications percentage, piecewise percentage, or some sigmoid. So lot of options would be available to improve your image quality. Also you can see few more options are there for different bands. And when I was discussing the image statistics and histogram, at that time I said that it is always better to spend some time on the histogram of the raw image, and if it is you are handling a false color composite, then for all bands which are involved there. See their histogram, see their statistics, minimum, maximum, mean and standard deviation and all values, because they will tell you that which enhancement or stretch will be better for your image which you are going to use. There are some other options in this particular softwares are also available, which I want to just mention few here, few more minutes here. That pen sharpening. Pen sharpening means if you recall the image merging technique which we have discussed, and that low spatial resolution multispectral image with high spectral resolution but panchromatic image. That is that image merging or image fusion, also called pen sharpening. That can also be done. Then you require a pen image for the same area, and that has to be of course georeferenced or a reference to this image also, and then you choose different methods. So, since I have not chosen in this case a pen image for input, so I am not getting other options, but by default it goes for IHS. And when I showed some results from this image merging, I too showed through this IHS, that is intensity, hue and saturation transformation. So, your original image first is split it into three components: intensity, hue and saturation, and then the pen or the pen image will substitute your intensity image from this color composite, and two hue and saturation will remain same. Again there will be backward transformation, and then you get an RGB image, false color image, in which the intensity image is coming from high spatial resolution panchromatic data. In this software, this is can be done very quickly, and that is what this option is, the pen sharpening. So, pen sharpening can be done here. Once you choose this one, then you get all these options available to you. So, that one has to really apply. So, whenever you handle any images, as I am repeating, first study the histogram, see the different bands, responses of different features present in the image in different bands. For example, vegetation, for example, water bodies, maybe forest land or a cropland and other things. And after studying image, after studying histogram, then as per the requirements go for appropriate stretch type. So, this brings to the end of this discussion about demonstration of software. Today I have used this ArcGIS, which is commercial software. Thank you very much.